Hello, this is ABC and welcome to Data Engineering and Infrastructure Community. Our today's topic is
The topic was notebook and to the deployment. With Databricks, with Jupyter Lab, with machine learning, with non-machine learning, it doesn't matter. Notebooks are now becoming pretty common norm of doing experimental programming and development. Some company even uses notebook for deployments. I don't know how. I know how, but I'm just saying it is a very complicated move. So I would really like to open the discussion for that. What is your view? How do you work? If are you at all using notebook? If you're using notebook, what is the next stage?
I think in general for data wrangling, data exploration, notebooks are really useful. Uh, the iteration, being able to block it, persist it, and then reiterating over it makes it very useful and makes it easier to go through the entire process. But essentially, for deployment, even I think it's very difficult to follow the best practices if you want to deploy from a notebook because when you're writing code in notebook, I've seen people just iterate and write code here and there, right? When they're trying to debug, they'll put statements over there, they'll put blocks, and essentially it's very difficult to replicate the same scenario because they might be executing one block in a different manner, right? It's not necessary you have to execute all blocks sequentially over there. That's what makes it wonderful as well. Like you can play around with it, but for deployment, it's very difficult. I feel to maintain over a long term. Uh, but for exploration, for testing out, for building basic machine learning model, testing it out, I think it's a good tool to play around with.
But Anmol, if you are by chance your some teams are doing any stuff in notebook, what is the procedure? How do you say, okay, you are done with now notebook? Now, how will you convert the code to your proper engineering or software engineering approach? Is it like one-to-one mapping, or adding test cases, or you just download the code from notebook and just paste it and publish it? How do you recommend, or do you have any experience on that?
So I would categorize it in different terms essentially. So they can be, I would say, they can be essentially exploration purpose, they can be model development purpose, or there can be some data engineering pipeline purpose for testing it out. Right? Now, if I think about the first two use cases, right? First two use cases, if even if you were to execute it on a daily basis, it's not that bad, right? Because essentially, it's not going to affect other systems. It's more of like when you think about exploration, you're developing some charts and stuff using matplotlib or anything for daily monitoring purpose. Even if it fails once or twice, that's not a big issue. So the code quality, because I'm expecting it not running multiple times a day, it might not be that great, but it gives you best in terms of the time and the return that you're getting. I think it's very valuable. Even for model development, right? Usually, once you develop the model, you store it somewhere in a registry or something, right? And then your production system might access it. So even over there, essentially, would you want to convert into a best practice code? This thing is questionable, right? Because the job was mainly to train a model, get it out there, and people can access them. Now, third thing which I've seen is data engineering pipeline. Right? That is where the trick comes in. And I've seen some. So some companies or some blogs, I don't remember exactly, but they have provided these tools where essentially with you can pass out Jupyter Notebook code and convert it into like a .py file or something, right? Which kind of makes it easier if you want to convert it into a productionalized code. It's much more easier to deal with. But I feel if you're getting into data engineering practices rather than using Jupyter Notebook for exploration, rather than using it for building some pipeline code, uh, I would use an IDE and put some unit tests in, some dummy data in my local machine. That makes things easier in terms of engineering standpoint. From the third use case is where I see it's very questionable. Do you want to use a notebook where you would write some unclean code and you have to productionalize it within certain timeline? Do you want to even go through that route? Rather create some uh, uh, a- an abstract class or something where you're defining your ETL processes, so that you stubbed out the main structure and then you can easily test it out on your local machine with some dummy data. But first two use cases, like I mentioned, right, that's where I think you do not have to worry about uh, Jupyter notebooks being run on a daily basis or something, because essentially, if it's not affecting other system, and you don't have to spend a lot of time, in terms of debugging it or exploring it, I think it's fine to deal with that.
I have a counter question to that. So it's a beautiful point what you just said. You don't need if you're just doing machine learning training, but usually machine learning has a pre-processing unit. Nowadays, pre-processing is usually done by data scientists because they understand data, they know what kind of transformation they are doing. It has two things. First thing is, since pre-processing for me is not data science, it is more like engineering problem where you just apply functions on data and you transform the data. It's more like a ETL. Another point is, okay, what about reusability? So for example, every time we are using certain set of steps in the machine learning paradigm, every time, and we are developing model, and one of this model will deploy in production. So is it fine that if the pre-processing part is completely separate, just for example, and only you are doing model training, which has a lot of hyperparameter tuning optimization, then you pick a model, then you deploy, then you do candidate deployment, then you validate your model is fine, and then you deploy, and you shouldn't have a linked, so you shouldn't have a way to go back to the history or replay back and go back to your actual code how the model react to that. You cannot reconcile back. So how do you recommend that? Like, do you think it is not relevant to always just for machine learning training to have a proper engineering approach? A notebook is enough?
So I, as a data engineer, feel that pre-processing should be separated out from the training aspect. For the reason being, when I think about it, right, you're constructing data, storing data. Uh, it can and should be reused by anyone. It should be available to anyone. So it should be separated out. Like, usually we think, okay, once I'm creating this data set, it's going to be used for my specific use case. But when we look at the whole picture, essentially, if you've done some work and someone else can leverage it, that should be possible. So in terms of best practices, I feel, if they're separated out, that's the best use case. Separated out, documented, essentially, this is what the data is for, this is what the structure is, and easily readable, easily accessible to everyone to explore or anything, or even to reuse it in later stage. I think that would be the case. So it's like, like you mentioned, essentially pre-processing being more like engineering, but essentially, since if you want to have a self-service platform where you want to be able to support users to do their own pre-processing rather than hindering and having a process where they have to rely on someone, you can try and create some kind of structure. Like, if you think about it, right, with Spark, essentially there's Spark SQL, right? A lot of data people are at least efficient in SQL, right? Now, if you think about it, if they can write SQL queries and stuff, you can wrap it around with Spark SQL on your end, and create some kind of a tooling, essentially, or a package which takes the SQL queries and runs it, right? So the users do not have to worry about actually productionalizing it. So that's how I think you can segregate it out in terms of thinking about machine learning aspect and the data engineering, like pipelining pre-processing aspect.
Okay, good. It makes sense. I mean, you are completely talking about abstraction as an engineering and completely separate data science driven, which can be very notebook heavy, and we don't care. Yeah, yes, it's actually a beautiful paradigm. Unfortunately, I couldn't make it work properly. Yeah, other points.
So, I think the notebook movement right now is getting traction because of the database, because they are basically, no,
I
at
will
least
disagree.
in India. at least in India or I'd say in the services
No,
industry.
but
So
Hitesh, before you move on, I just sorry to
yeah,
interrupt, but the main point with the data notebook is not at all database. Nobody gives like biggest point is Jupyter Lab when
yeah.
because
Biggest point is Jupyter Lab. Yeah, I'm coming to that point. Okay, I'm coming to that. Uh, so I've been customer of Databricks since you can say almost the start of my career because uh, we were using Databricks when they had this 200 or 300 flow from in 2016. Even before that, they were using, but when I joined the project at that time, they were still using in Lambda. So I have seen them evolve. So earlier, it used to be same as the Jupyter Lab. So you have to do everything how it can be done. So lot of things they have solved. So that's why they got into the lakehouse paradigm. So that's why they got in the keyword of lakehouse. The same way the Amol just explained. So whatever pre-processing you have done to any data that should be applied to all the data and that should be available to everyone for the self-service. That's what their concept is, and that's how they are moving forward. Apart from that, moving the code from the Jupyter Labs or any other notebook into the production. So the common thing is what I would do is basically whatever the common functions that are being used, what we do is we basically move that into one library, make a jar of it, and that is available to everyone. Okay, so I have my abstraction, I have my common utilities available to everyone, and whatever the code you are writing, you can write in your notebook, and that notebook file can be used as a file for the developer for the deployment. That's how we used to do the notebook deployment. But normally, in the case, let's suppose for testing, you have written something. Okay, all right. So you have written something for testing. This method is and you want to use it, and it is a common method or common utility which can be utilized by everyone. Okay. So once that notebook comes to us for deployment, what we do is basically we extract that thing and move it into a common utilities project, and we make the changes into that notebook, and then we used to post on our document sharing site. Okay, so this is how done, and if you want to use this thing, so you can do this thing and how you can use it, and then that can work. But it adds another step for the data engineers to do, or someone who is let's suppose someone who is not into the who is not doing the deployment again and again, but he's writing the code. So that is where we had an sort of an issue because when you let's suppose when you have 500 different users and there are just 3 users to handle the deployment and all this stuff, then it becomes a big issue. And what can be a common utility, what cannot be a common utility. So basically, everything is a problem when it goes to some sort. So if yeah, so if you do not have much skill, then notebooks are fine. Okay. You don't have any issues. Okay, so let's suppose your logic can be done in 300 lines, 400 lines, no issue. You are I'm happy to I'm happy to help you to use notebook. You use your notebook. I do not have any issue. But as soon as it crosses 300 to 400 lines, then it starts becoming an issue because the maintainability of the code goes down, and as the mentality of code goes down, so the what you call the collaboration will also go down because I do not like to look into the 300 lines of code written by anyone else because uh, and if I was supposed to work in someone else's project, what I normally do, I just take out the logic and write my own code again, instead of working with someone else. And that's how anyone will prefer if their coding style is completely different.
Yeah, I wanted to add something. In general, it's also about thinking about the manpower resources you have, right, and the time you have for development of a project, right. If you think about it, if you're trying to create a self-service architecture, and if there's some deployment needs, essentially notebook, if you like, it's the easiest way for an end user other than engineer to actually build something and deploy it quickly. So in terms of time, it might make sense to have that deployed if it's not affecting a lot of system. Go ahead and deploy it, and later, like, you can essentially create a backlog ticket or something that this needs to be addressed later. That is also how I feel, essentially it helps in general planning and deployment stuff, because it makes the process faster, because essentially in terms of engineers, you might have relatively less engineers, and it's difficult for them to allocate to each and every project. So in that way, people can deploy it, it can run, you can iterate over it, and then once it's stable and feels like the code is essentially accomplishing what it was supposed to, but now it might start affecting other criteria, like it might be costly to run notebook, it might be resource heavy or anything. That's when you can go later on, plan and allocate resource to it to actually productionalize it in a much more efficient way.
Great points. Okay, so I really I really tag along with all the points around the notebook. So I have faced all of them. So there are few tiny details which nowadays changing the paradigm. First, notebook as a behemoth, I would say there is an elephant in the room for the notebook, which is SageMaker, and another is Kubeflow. I mean, they both are same. They both are. It's like an animal. It's a dinosaur. It's not even an elephant. It's a dinosaur. So they give so many different kind of permutations and so much power that a data scientist or machine learning expert can invest their all time and doing every crazy thing they want. And there is nothing wrong in that. I mean, as Anmol mentioned, that the engineers are scarce. Like, we are already busy with so many different activities that even we don't want to like pull for all the problems. So what we do, yes, we did ETL. We have all this fancy data warehouse, but that is maybe not enough. For a particular business problem, they need to do some kind of different transformation. And why I use the word is, it was not supposed to be pre-processing there, but yeah, it is here. It is already there. And they know they can just click on a notebook, maybe Databricks, and they know Spark cluster is there, so they don't care. They need not to ask me. They need not to ask anyone. They can just attach to that particular Spark cluster. Same with in SageMaker, they create a PySpark notebook and they start writing their PySpark code. And then you introduce to the point where there are code, business logic proper, and then machine learning model. And nobody anticipated it. It just came. We didn't have time. We are busy. Release is on the way, and you will do it. Like, you are not going to hurt the business just because engineers are not available. And I have tool. I know how to code. I will code. And that's where the come of the gap which Hitesh mentioned on library. So my libraries always runs out of time. That first. Second, how will the right libraries are written? If there is a function which was changing, for example, which was adding, which is hashing a age, and now you have creating another function which has a name, which is hashing the name. This is creating a hash code on the name. You forgot about it that you already has a hash code on the age, because you know hash age. Now you create a one more function, hash name, because you are as well running out of time. So now maintaining this library clean, because then you don't need that. You need an abstraction, just a headmaster and pass it on. I just gave a very blunt dummy example, but just saying this creates a code debt. A tech debt is already creating in this libraries. And I have seen the point when somebody says, this is a bad library. It is so much tech debt. It is such a stupid library. I have so many duplicate functions. And now that's a problem. So what I meant here is, in nowadays with the notebook environment, it is great if you could enable data scientists to do the work if they can do it, and we pair with them. Pairing is way better than completely decoupled structure, because you really don't know the intent of their work. And maybe after pairing with with them, okay, you need not to do this. We have this library. Maybe you can reuse it. Let's pair. So I would say I cannot stop notebook, and notebook will be more and more dominating because this is fast. You can plot things on over there, you can share right over there, and it is easy. It's an interactive way of doing programming, and not everybody is developer that you will like VS Code or Terminal to work with. I'm not using Vim nowadays, but I know people love Emac and Vim to work with. So that's where the paradigm shift is all about now. You can use Notebook, but you need to have a very solid collaboration with data scientists to really know what they are doing, because one day someone will come and say, all of you are doing a chaos, it's time to refactor. And that refactor word, whenever comes, it's a nightmare, because it's like, where should I start this new refactor? What should I refactor? Data engineering refactor, data science refactor, infrastructure refactor. And then one day you will make a rule. From now on, we will do this. And again, things will change. So I'm just saying, nowadays it is, I mean, say all these services are giving so much power. It is a shame that we will have to stop data scientists to not use them. It's a power to them. They can use PySpark, they can use all this crazy deep learning libraries, they can even code on Dask directly. So suddenly someone like, oh, PySpark is not cool, I will use Dask. Damn it. So now you have introduced one more framework to do the same processing, and it is happening. I mean, I don't know have you if any of you experience or not, but I've seen some smart data scientists in previous company work on rapid AI and Dask, and he just actually outbid Spark. He said, my code is this much, it is so smart, why will I use PySpark? He's not wrong, but I was stuck because my entire engineering was built on Spark, and then somebody brought a new library. What should I do now? So I'm saying that is the problem. When I see Notebook is not the only problem, culture, adoption, discussion, collaboration, and finally, I hate notebooks when somebody says I deploy in production, but we need to do it. Like, you know, SageMaker API can deploy your notebooks in production, and they have a CI/CD, they have everything, and so it's sometimes hard to convert that notebook code to a source code, but there should be a way that you don't need to do this, maybe in future. But that's my take on notebook and moving to deployment. And for me, I still insist on pair notebook. Each notebook should be paired with one of the engineers. There should be code review for all the code, even for the machine learning code. There's a style, there's a code style of writing, there's a style of putting logs. If you're using visual metrics and tracing, then there's another style. So that's why I insist on that. But naturally, what Anmol shares, you won't find engineers all the time, and maybe your engineers are not interested in doing that. They will say, what am I doing here? So yeah, that's a trade-off of notebook and programming, engineering, I don't know, whatever you call. That's my version on notebook. Any other point?
Actually, yeah. Actually, I forgot about the SageMaker. So I have seen people. So what they do is they basically do everything there in the SageMaker notebook. Basically, what they do is basically first create a notebook, first create a S3 bucket, copy the data into that S3 bucket, do all their work, and at the end of their code, they are deleting that bucket and just put. That's, I was shocked to see that. I was shocked to see that. So I was like, what? So and his notebook was such that he was validating each and everything. Okay, so my notebook, is my notebook created? Okay, it is created. Okay, so now okay, so do I have all this permission to do this thing? He was creating roles in there and then doing all this stuff and then doing the actual. Okay, so now he starts reading the code and uh, and the documentation in that code. So it was like he had written a book, complete book, how to do his complete program end to end in that notebook itself. Uh, he used MD for okay, so this thing, okay, so there was big comments and everything. I was shocked. How can someone put so much effort while writing a notebook?
But that's the thing, right? Some data scientists go deep on the data. So like I work with teams who really don't care machine learning algorithm. They do care data cleaning. Quite a lot of different libraries, matching maker library, probability matcher, Bayesian statistics. So those are deep on the data, and as a data engineer, I will say, no, I don't understand them. what is these things, what kind of libraries are this. And that's what the problem comes. Like if you invest quite a lot of time on data cleaning stuff, even data engineers doesn't know all those libraries. They won't even have understanding what is this population matching. My team uses it, and I scared to, like, don't show me, I don't understand that library. But it's an engineering thing. What they are doing is they are just wrapping that library, changing that library to make that data perfect. And that is engineer, I mean, that is a code. It's a proper source code. It is not some PySpark or it's a Python, but source code. Now that's a challenge, is it's a notebook code, or it's a proper development and systems. And that is my point, that we are coming to that era that data scientists are no more only training model. They are using very different kind of complicated libraries to do the data cleaning, and notebook is a very good tool, and we will have to somehow leverage that to make it productionize. I don't know how, but yeah, I mean, I'm trying, as Hitesh and Anmol mentioned, those are the steps I'm as well trying. But yeah, I was saying that every day the new problem is coming. So yes, maybe hopefully we'll fix it. Okay, good. If we have anything, is there anything else to add to these two topics?
I was just wondering if you want to discuss in terms of notebook the difference between Jupyter, using Jupyter versus Zeppelin, if it might make sense.
Yeah, so you should stop Zeppelin, because Zeppelin founder is now the part of Databricks.
Oh, okay. I did not know that.
So Zeppelin founder is now part of Databricks. He has joined Databricks. So you and me pretty well know what is happening to Zeppelin. So
Yeah, I heard it's becoming dead, but okay, I didn't know this was the case. Thanks.
Actually, lot of different library founders have joined database in past 1 year. I actually don't remember the name of the library. It was relating to the feature store. So he was the co-founder of it. Now he works in Databricks. So a lot of people are joining in Databricks, right?
so there are now two notebooks, Databricks
Yeah.
or Jupyter Lab,
Mm.
and they too will be there. But the point is, that is good, by the way, because now we have less thing to take care. This 10 different notebooks create more problem. At least we have
Yeah.
two. Let's deal with only two. Like, but if it comes to complete machine learning notebooks, like my teams are using, I tried other notebook, I will still say Jupyter Lab just outbid Databricks. Like, if it is machine learning and data science, Jupyter Lab is just the de facto to work with. I mean, it is just brilliant. It is super powerful, and the plotting and structuring is way better. But if it is Spark, don't even look for Jupyter. Just see Databricks. They're pretty mature and different. Okay.